In this video, I'm going to discuss about or I'm going to continue from the last video or last topic. It is about database designing. So here we are going to start with the first normal form, because whatever discussed in the last class is that we need to normalize the data bases or data we are entering in the database. So what is first normal form? The first step in normalizing a relation is to remove the repeating groups. In our example, the unnormalized relation sales report will be broken into two separate relations. This new relation will be named as salesperson and salesperson customer. So here you can see this relation, this is unnormalized relation sales report, has been separated out as salesperson and salesperson customer. And then figure 30 so how the original or unnormalized sales report is normalized by separating the two relations into new relations. Notice that the relation salesperson contains the primary key salesperson numbers. Salesperson number is the primary key, and then the primary key of salesperson is salesperson number, as well as the attributes that are part of the repeating group: customer number, customer name, warehouse number, warehouse location, and sales amount. Knowing the salesperson number, however, does not automatically mean that you will know the customer name, less sales amount, warehouse location, and so on. In this relation, one must use a concatenated key, both salesperson number and a customer number, to access the rest of the information. It is possible to write the relation in shorthand notation as follows. Here you can see this is salesperson. In case of salesperson relation, only the salesperson number is the primary key, but in the salesperson customer, both salesperson number is the primary key, along with there is a concatenated key, that is customer number, that is here you can see. Both using both number, any attribute or any relations can be derived. But initially what happened in that sales report, due to that non-division, their grouping occurs or repetitive occurrence of data occurs. So that is why they try to normalize the thing using first normal form. So in the first normal form, is our main aim is to remove the repeating groups. So whatever data or whatever group of data is repeating in your relation or in your table, you need to remove that. That is the talk about first normal form. So here in this example you can see also here this main relation has been separated out or divided in two different relation. Here salesperson relation and a salesperson customer relation, and to access anything from this table you can use the salesperson number as a primary key, and to access any data from this table you can use salesperson number as a primary key, and along with that customer number as a concatenated key. In other words, some of non-key attributes depend on only customer number and not on concatenated key. The data model diagram in figure 13.7 shows the sales amount is dependent on both salesperson number and customer number, but other three attributes are dependent on only customer number. So here what you can see that some attributes are dependent on customer number and some are not. Here that is what it is saying. Sales amount is dependent on both salesperson number. This sales amount is dependent on both salesperson number and customer number, but other three attributes are dependent on customer number. Other three attributes depend on only customer number. So that is why in the second normal form all attributes will be functionally dependent on the primary key. So here what you see, some attributes does not depend upon the all the keys or primary keys. Only sales amount is dependent upon the primary key along with the concatenated key. So that is also a non-normalized form, because after removing the repetition we might find this type of situation where that dependency might not be there with the primary key. So that is why in the second normal form all attributes will be functionally dependent on the primary key only. So that is why all attributes, whatever attributes in the relations are, will be functionally dependent on the primary key only. Therefore, the next step is to remove the all partially dependent attributes and place them in another relation. So if there exists any partially dependent attributes, then we need to place them in another relation. Figure 13.18 shows how the relation salesperson customer is split into two relations, sales and customer warehouse. This relation can be also expressed as follows, like that. So here that salesperson customer, this one salesperson customer is now split out because some attributes are dependent upon this one and some attributes are dependent upon both one. So there are partial dependency is there. That is why to remove that, they divide the salesperson customer relation into parts, customer warehouse and sales, so that everything directly dependent upon the primary key, because customer number is primary key in this table. And again here with the sales amount, both salesperson number, customer number are here, but and anyhow sales amount is directly dependent upon salesperson number and customer number. So that in that way we can remove the functional dependency. So here you can see sales is salesperson number and customer number, both are the keys here, but salesperson number is the primary key and customer number the concatenated key. But in the customer warehouse, customer number is the primary key. The relation customer warehouse is in the second normal form. It can still be simplified further because there are additional dependencies in the relation. Some of the non-key attributes are dependent not only the primary key but also non-key attribute. This dependency referred to as transitive dependency. So again one problem occurs here is that figure 13.19 shows that dependencies in relation customer warehouse, for relation to be second normal form, all attribute must be dependent on the primary key. That is all values should be dependent on primary key, that is customer number. So in the diagram, warehouse location however is obviously dependent on warehouse number. So warehouse location is anyhow dependent on warehouse number, though they might be dependent on customer number, but warehouse number is dependent on this. So there is a transitive dependency, means this is dependent on this and this is dependent on this. So there is a transitive dependency with the customer number for the warehouse number. So that type of dependency also we need to remove after getting the second normal form. If there exists transitive dependency, that is also we need to remove, and that is why we need to go for third normal form. So first normal form all about was to remove the repeating groups. Second normal form all about is the remove the partial dependency. Third normal form is all about the removing the transitive dependency. So third normal form is here you can see third normal form. A normalized relation is in the third normal form if all the non-key attributes are fully functionally dependent on the primary key and there are no transitive dependency. Non-key dependencies means there should not be any transitive, or you can say non-key. Suppose some attributes are non-key, not a key, then there should not be any dependencies. In a manner similar to previous steps, it is possible to break apart the relation customer warehouse into two relations. So again, the customer warehouse has been divided into different relation where customer and warehouse is divided in two relation, and here warehouse number is the primary key, but here customer number and warehouse number both are connected with the customer name. So in that way, the primary key for relation customer is customer number and the primary key for relation is warehouse is warehouse number. So in addition of this primary key, we can identify warehouse numbers to be a foreign key in relation customer. So warehouse number in case of customer relation is a foreign key. So we can access this table also using this foreign key because those are connected. A primary key, here you can see a foreign key is any attribute that is non-key in one relation. To try to understand that, a foreign key is any attribute that is non-key one relation but a primary key another relation. We designated warehouse number as a foreign key in the previous notation in the figures by underscoring it with the dashed line. So here you can see finally the original unnormalized relation sales report has been transformed into 4 3NF relation. So original this one has been separated to third normal form like this one, where salesperson is the first relation, second relation sales, then customer, then warehouse, where you can see these things are, the dashed lines are primary key. The third normal form is adequate for most database design problems. The simplification gained from transforming an unnormalized relation into a set of 3NF relation is a tremendous benefit when it comes times to insert, delete, update information in the database. An ER diagram for a database is shown in the figure 13.22. We'll see that, but try to understand this. Now we have divided the original table into this 4 table to create this dependency free and repetition free, so that it is normalized one. So you can see the ER diagram also here, where salesperson is connected with the sales, and sales, because salesperson, here you can see what is the connection. Salesperson number and salesperson number is same, so in both relation, then both are connected with the salesperson number, that is why both are connected. And again, sales is related with this one, customer number, and with salesperson number. So customer and salesperson number, so customer and salesperson relation. So, and again, customer is related with warehouse, because the warehouse is foreign key in both cases. So here you can see salesperson only one salesperson is connected with generate sales. One salesperson generates sales, and sales are made by one or more than one by salesperson, and sales are purchased by customer. One or more sales are purchased by customers, and one customer agrees to sales, and then customer receives from warehouse. One or more customer receives from warehouse, and again warehouse sends to one warehouse sends to customer. So here for every this is one relation, this is one relation, this is one relation, 4 relation, and all things you can see here, the attributes values. Okay, so this is a ER diagram for the database. Okay, so we can see here one to many relationship, okay, or many to many relationships. That is, we have discussed in the last video also how we can show them. Now we'll try to understand what is the guidelines for master file or database relation design. Here you can understand by reading this context, like each separate data entity should create a master database table. Do not combine two distinct entities on one file. For example, items are purchased from vendors. The item master table should contain only item information, and the vendor master table should only contain vendor information, and you cannot item master and vendor master include in one file. That is why this is one guideline, is that each separate entity should create a master database table. Do not combine two distinct entities in one file. A specific data field should exist only one master table. So any data field, any specific data field should exist only one master table. For example, customer name should exist only on the customer master table. Not on the order table or any other master table. The exceptions to these guidelines are the key or index fields, which may be on as many tables as necessary. So there are some exceptions, like here what is saying that a specific data field should exist only one master table. For example, customer name should exist only on the customer master table, not on the order table, but that rules can be changed, or we can manipulate that rule if some keys or some fields are like key, primary key or foreign key or some index field, then we can nullify that rule, which may be on as many tables are necessary. If a report or screen needs information from many tables, the indexes should provide the linkage for obtaining required records, and each master table or database relation should have programs to create, read, update, and delete the records, include ideally only one program should add new records and only one program should delete specific records. Many programs, however, may be responsible for changing data fields in the course of normal business activities. For example, customer master file may have a current balance field that is increased by the order total in the order processing program and decreased by payment amount on the amount returned from two additional programs. So update can be done by more numbers of operations or activities or procedure, but create and delete should be specific and separated programs. And after that, we need to know about what are the integrity constants. Integrity constants are rules that govern changing and deleting records and that help the data in database accurate. Three types of integrity constants apply to a database and you need to follow this integrity: entity integrity, referential integrity, and domain integrity. So what is entity integrity? Integrity, that is, constants are rules that govern the composition of primary keys. The primary key cannot have a null value, and if the primary key is a composite key, none of the component field in the key can contain a null. So try to understand this is like that. Primary key is very important part or field in the database or that relation. So if any value in the primary key field is null or zero, then you cannot access the samples or data from that table. So it should not be that. The value should not be null in case of primary key. And if the primary key is created by composing one or more key, then also any field of those combined fields should not be null. And what is referential integrity? Referential integrity governs that records in one-to-many relationship, the table that is connected to one end of the relationship is called the parent, and table connected to many end of the relationship is called the child table. Referential integrity means that all foreign keys in the many table must have a matching record in the parent table. Hence, you can not add a record in the child table without matching record in the parent table. Suppose there is a parent table, okay, and there are three child table, okay. So if there is a foreign key in parent table and those foreign keys are here primary key, okay, so here primary key, so these are connected, okay, these child tables are connected. That is why it is saying referential integrity means that all foreign keys in the many table, these are many table, or you can say child table, must have a matching record in the parent table, hence you cannot add a record in the child table without matching record in the parent table. So that is the referential integrity and it should be there. And referential integrity, you can go through this context, has many things to understand. Referential integrity is implemented into different ways. One way is to have restricted database in which system can update or delete a parent record only if there are no matching child records. A cascaded database will delete or update all child records when a parent record is deleted or changed. A restricted relationship is better than deleting records. You would not want to delete a customer record and have all the outstanding invoices deleted as well. So suppose, because there are relation between the child and parent, so some file if you delete it, then all the other connected files also will be deleted. So rather than deleting them, you can create a restriction on those relations so that it does not get deleted all the data with relation with the parent. The cascaded approach is better when changing records. If primary key of a student record is changed, all the course records for a student would have their foreign keys changed as well. So that is where also it is better, because in the cascaded one you put a restriction, or you can if the primary key of the student's record is changed, if the attribute or key is changed, then also all the connected tables data also will be changed. Or if that data related to the parent, uh, if the parent data is deleted, then child data will be also deleted. And to stop that thing, you can restrict that relationship so that deleting does not occur. That is why cascading database is better than deleting database. And again, the last one is domain integrity rules are used to validate data such as table limit, range, other validation checks. They are further explained in chapter 15, and we'll try to understand it in data. But main point is that it is about validating the data such as table or limit or range and other validation checks. So these are the integrity constants need to follow by any databases. And in case of databases, there might be anomalies. 4 anomalies may be occur in databases while creating databases. Data redundancy means repetition of data. Insert anomaly means there might be some data which is inserted but not belong to the data, belongs to that relationship. Deletion anomaly, unknowingly you have deleted something which should not be deleted. Update anomaly, suppose mismatch or replaced item has been updated or not with no relation with the actual relation. So data redundancy occurs when the same data are stored in more than one place in the databases. That is data redundancy. So to remove that, the problem is solved by creating tables that are in 3NF. So by creating 3NF table, that thing will be solved. And what is insert anomaly? What is insert anomaly? Insert anomaly occurs when the entire primary key is not known and database cannot insert a new record. Suppose entire primary key is not known, then you cannot enter any table or any data values in the relation, and which will create the entity integrity, and thus this problem will lead to insert anomaly. And what is deletion anomaly? Deletion anomaly happens when record is deleted, resulting in the loss of other related data. And that is why also due to the referential integrity, there might be a relation with parent and child tables, and if you delete the parent data, then also the other data with the child table will also get deleted. Then that is also a deletion anomaly. So you cannot, or that should not happen in case of databases. And fourth one is that update anomaly. Update anomaly results when a change to one attribute values either causes a database to contain inconsistent data or cause multiple records to need changing. So that is a update anomaly. When the anomaly occurs when you are going to update the table. An example is when you street names change in a city, you might change some of the street names, not others, or you will have to ensure that all street names have been changed. This can occur when you have transitive dependencies and may be prevented by creating tables that are in 3NF. So by using 3NF also you can remove this anomaly, that is update anomaly. So in case of deletion anomaly, an example is that an item that has a vendor number and a particular item is the only reference to a certain vendor. If that item is deleted, there will be no reference to the vendor record, and that will be a problem. So you can see what are the anomaly can occur in case of database creation. So here you can see how we can data retrieve and present it in 8 distinct steps. Suppose this is the warehouse. You need to choose relations from the databases. Relation means tables. Join the relations together. You can join the relation using the primary keys or the foreign keys to match up them in a single relation. Project columns from the relation. Whatever projection, whatever columns you need to project, you have to put them in a single relation. Then select rows from the relation. From that relation you need to select those rows that you need to show. Derive new attributes. From that thing you can derive new attributes. Okay, you can create the new attributes. Index or sort rows. You can index the rows or sort the rows. Then calculate total and performance measures. Try to calculate the totals and performance measures, and again present the data. So that is the way to retrieve and present data in 8 different steps. So that is the discussion we are doing actually on this one. So next is about data warehousing, but we don't need to cover that part, but try to understand what is database designing procedure, how we can design this. And it is very important in case of any application design where database is very important. And try to understand and try to go through the examples whatever mentioned here, and it's very understandable, very easy to understand. And if you have any problem to understand or anything need to learn, or if you're finding any tough understanding this, then let me know. We'll discuss over Google Meet. Thank you.